At grade 8, we're going to now look at the second phenomenon. The notes on this is on page 9 in the handout that you were given, or that's available on Google Classroom. The second phenomenon is this. Here we have a ruler, perfectly straight ruler. I'm going to place it inside this glass now. And you will notice that this perfectly straight ruler sometimes appears bent in the water. Now the question is, why does it appear bent? Okay, and the phenomenon is because of the fact that light can refract as it moves from one optical medium into another. In this case, the one optical medium will be air, and the second optical medium will be the water. Okay, so that's two different media, and the light is traveling from the ruler through the water, one optical media, then through the glass, second optical media, and then through the air, that would be the third optical media. Okay guys, grade 8, we're doing the second investigation. We are going to investigate the refraction of light as it passes from one optical medium into another. In this case, we are going to once again need our ray box over here. We're also going to need a rectangular glass block over here and some drawing implements. That would be basically a ruler and a pen or a pencil. Okay, so let's switch on our ray box here. Right, so we have our incident ray coming in a straight line. So I've drawn an outline of the block that I'm going to be placing into this outline. So here is the block, placing it in the outline. Exactly. And you will notice that I've placed the block in such a way that the incident ray is hitting this block at exactly 90 degrees. And as you can see, the light emerges on the other side from the block at exactly 90 degrees. Okay, so no light is being bent here. It's moving from air through the glass back into air, and it seems to be moving in a straight line. Okay, because the incident ray is exactly 90 degrees to the normal. Okay, so that is the drawing that one has there for page 9, and you have to then write down your observations for that one. So what we're going to do next is we're going to go to page 10. On page 10, what I'm going to do is the following. I'm not going to let the block stand at exactly 90 degrees. I'm going to, you see here, I've angled the block. Now you notice, incident ray over here seems to be going through the block and emerging on the other side of the block, but not in a straight line with the incident ray. It's parallel to it, but it is not in a straight line. So let's just mark off those points quickly. So I'm going to just draw the block outline here again. So there's my block outline. Here is my incident ray, starting over there, going to over there. And here's the emerging ray from there, let's say till there. Okay, so now I'm going to complete this drawing and draw in the normals and then look at the incident and the reflected rays. Okay, so that is as far as that's concerned. So I've drawn in the rectangular glass block. I've drawn the incident ray from the ray box here as line AB. Then the light has traveled through the glass box, and you can see it as bent here. That line is going to be BC, and then CD is the light ray that is emerging. They call the emergent ray. Okay, in red I've also indicated the positions of the normal. Okay, so the first thing is we're going to do is, let's look at this first part here. Where is the angle of incidence here? The angle of incidence is between the incident ray and the normal. So that angle there is the angle of incidence. And the angle of reflection, refraction, not reflection, the angle of refraction is going to be between the normal and this ray going through here. So we're going to have to measure those two. Okay, then that ray now becomes the incident ray as it moves from the glass back into the air. So here we're going to have a ray going here, BC, and the angle between the normal there and that ray there, that's going to be my new angle of incidence. And then it gets refracted as it moves from the glass back into the air between the normal and the emergent ray, and that is going to be my angle of refraction. Okay, so what I would like you to do is just measure those angles and see if you notice anything about them using your protractor. Okay, thanks a lot.